Hi, my name is Mallorie, and today I'm going to be talking a little bit about my science fair project, which is interrupting cell-cell communication in pathogenic bacteria. So antibiotics have been in use for almost 100 years, and this is creating a little bit of a problem because the bacteria that is being treated using the antibiotics is becoming antibiotic resistant. And antibiotic resistant bacteria is when bacteria take in the antibiotic to make itself stronger, therefore making it very difficult and in some cases impossible to treat. So the purpose of this experiment was to find alternative ways to treat pathogenic bacteria without the use of antibiotics, therefore preventing antibiotic-resistant bacteria. So I did this in Streptococcus pyogenes, or more commonly known as strep throat. And the first thing I did was I found out the way that strep throat communicates. And what I found out is it communicates using something called quorum sensing. And quorum sensing is when the bacteria sits in the back of the throat, and what it does is it simultaneously counts itself. And when it simultaneously counts itself and feels like it has enough of itself to overcome the massive host of the human body, it releases this go signal. And this go signal is a positive signaling molecule that basically tells the bacteria to go. And when the bacteria receive this signaling molecule, that's when they start to release toxins, and that's when you start to feel sick and symptomatic. So this led to me thinking, what, if any, effect does negative signaling molecules have on pathogenic bacteria that uses positive signaling molecules? Would it be able to interrupt that signal, therefore not allowing the bacteria to communicate or ever release the toxins, therefore potentially you never being sick? So my hypothesis was that both N-butynyl D-L-homoserine lactone and N-hexanyl L-homoserine lactone would inhibit the growth of the Streptococcus pyogenes. These are both negative signaling molecules that are used directly in quorum sensing. So my independent variable was the different type of homoserine lactone that I was introducing. My dependent variable was how many colonies were growing on each agar plate. And then my control variables were everything that I was keeping the same. So for my procedure, I took 11 blood agar plates and streaked the plate with the Streptococcus pyogenes. And then on 5 plates, I took 1 milligram of N-butynyl D-L-homoserine lactone and placed it in the middle. And then on the other 5 plates, I put 1 milligram of N-hexanyl L-homoserine lactone in the middle, leaving 1 control plate. I then put them in the incubator, and at 24 hours, I got them out, and what I did is I made 2 measurements in the agar plates. One measurement at 33.1 millimeters, which is the center of the plate, and then one measurement on the outer rim of the plate at 14.3 millimeters. I then put a piece of grid paper under the agar plate and put both the grid paper and the agar plate under a dissection microscope. At the 2 measurements that I made, I counted how many colonies were in 1 square of the grid paper. I did this twice, yielding 2 different trials. Then, because of time and money restraints, I could only do a 3rd trial with one of the chemicals. So I chose the N-hexanyl L-homoserine lactone. And in the 3rd trial, it was the exact same procedure, except I was doing it with 5 plates. So 1 being a control plate and 4 being test plates. I then also ran what I call a chemical control test, which is I took a blank blood agar plate and put 1 milligram of the N-hexanyl in the center and let it, put it in the incubator for 24 hours. I then came back to make sure that the results that I was getting was not an interference between the negative signaling molecule and the agar, but the results that I were getting were because of an interaction between the negative signaling molecule and the bacteria. My results were astounding. My control plate had 67 colonies in the center measurement and 53 colonies in the outer measurement. My butynyl took those numbers way up. In the center it had 672 colonies, and in the outer measurement it had 581. My hexanyl took it the exact opposite way, with only 5 colonies in the center measurement and a mere 12 colonies in the outer measurement. My trial 2 plates followed the same exact trend lines, with my control having 60 colonies in the center measurement and an average of around 59 colonies in the outer measurement. And the plates that had the butynyl placed on it followed the same exact trend lines as in trial 1, with an average of 650 colonies in the center measurement and an average of around 590 colonies in the outer measurement. Then, again, the hexanyl took it the exact opposite way, with an average of 5 colonies in the center and an average of 50 colonies in the outer measurements. So then for trial 3, again, the hexanol followed the same exact trend lines. The control plate in that trial had 69 colonies in the center and only 59 colonies in the outer. And the hexanol had an average of 5 colonies in the center and only around 60 in the outer measurements. So my conclusion was that the N-butynyl D-L-homocystine lactone was actually acting as a catalyst for the growth of the Streptococcus pyogenes, while N-hexanol was being an inhibitor to the growth and reproduction of the bacteria. So this has a lot of different applications. One is that it opens the door for other scientists and other researchers to find out the way that different pathogenic bacteria communicate. It also allows them to go in there and find exactly what they're communicating with and cut off that communication. Therefore, they can never release their toxins and never make you sick. This presents the possibility of coexisting with the bacteria instead of trying to kill it, therefore risking antibiotic resistance. It also presents a possibility to solve the problem of the antibiotic resistant crisis. So for future research, I would want to do this experiment again with larger amounts of the N-hexanol. I also want to find out the exact concentration at which it inhibits the growth of the Streptococcus pyogenes. I would also want to see the effects of the N-hexanol on human beings. We know that N-hexanol L-homocystine lactone is used in agricultural production, so there is a possibility that there are trace amounts in your body. I also want to see exactly what is happening between the negative signaling molecule and the bacteria. This can be done using something called Molotov, which is a soft ionization technique that allows you to see the different distribution of the different particles. So that was my science fair project this year. Thank you for listening.